Thank you. I'm working in University Dental School and also working in University Dental Hospital. This is my first time to visit Vietnam. The first was in 2012 around the Guangxi area. The second was in 2013. I met a new year at that time. And third was 2015. As you can see in the picture, I came to Vienna for volunteer service of our university. We treat over 1,000 children during 3 years. I still remember the pure and bright smile of the children. I feel very happy in that time. This is winter snowy time of my school. There are 11 dental schools in Korea. I teach students in these buildings and also treat patients in this building. This is my department of conservative dentistry. We have 18 unit chairs and 12 professors, 9 residents, and 3 dental hygienists. This is a example of unit chairs. You can see many monitors in here. This is for chart or records, and this is for radiograph, and this is radiograph for patient, and this is for microscope. We have 13 dental microscopes. We are doing many composite restorations every day. Composite is very good materials because it has a tooth color and bonded to the tooth structure. But it shrinks during the polymerization. They can cause some problem. So patient and dentist wants the durable, long-lasting restoration without any post-operative hypersensitivity. So this first session, I will show my clinical procedures for composite restoration for posterior area and explain why I do like that. You can see mesial-occlusal class 2 cavity in here. The matrix in which is applied is ready to restoration. The first step for the composite restoration is the making preparations and some surface treatment for bonding the structure to bond to the composite. As you know, the adhesion to enamel starts with the acid etching application. After then, apply the unfilled bonding resin, and the composite will be bonded to the bonding resin. So, making a micromechanical interlocking. This enamel adhesion is very strong and not changed for a long time. So I applied 37% phosphoric acid to the enamel area, and not from the bottom of the cavity that draw the boundary. And then apply etchant to the dentin as quickly as possible to make the dentin surface contact with the etchant at the same time. There are several ways of acid etchant application by some different adhesive. In self-etch adhesive, we don't have to apply acid etchant to enamel. But I recommend selective etch technique like this because self-etch adhesive cannot reliably etch the enamel surface. In universal adhesive, you can apply acid etchant to the dentin or not. If you use total etch adhesive, we should apply acid etchant to the enamel and also to dentin. Dentin structure is more complex compared to enamel. Dentin is a dentin tubules, so dentin structure is wet and more organic compared to enamel. And the component of dentin in the superficial area and deep area is different. It is inhomogeneous. And the smell layer will be made after instrumentation. So the adhesion to dentin is more complex compared to enamel. In the past time, we tried to put the composite resin into the etched dentinal tube to make a mechanical retention. But it was failed because here is a wet surface. Resin cannot penetrate to the dentinal tube area. So nowadays, many researchers change the viewpoint about the more larger area between tubule. We call it intertubular dentin area. You can see many porosities where the etched dentin surface because of a collagen fiber network. Modern concept of adhesion to dentin was developed in around the 1980. The first step of dentin adhesion is using acid etchant to remove minerals around the collagen fiber. After rinsing etchant, primer will be used because water takes a place in there. Primer has two basic characters. It has a hydrophilic and also has a hydrophobic characters. So it can penetrate to the water, and also it can promote the infiltration of a bonding resin. So after we apply primer, we apply bonding resin to there, and composite resin can bond to that area. We call this area as a hybrid layer. So the dentin adhesion is also micromechanical interlocking. So this etching, priming, bonding three-step procedure for dentin adhesion, we call it fourth generation of adhesive. And to reduce the steps of adhesion, fifth generation and sixth generation and seventh generation adhesives were made after that. Fourth and fifth generation adhesive etches enamel and dentin, so they call total etch system. And sixth, seventh do not use acid etchants, so we call it self-etch adhesive. Total etch systems remove smell layer, but self-etch system modify the smell layer. Nowadays, we can use universal adhesives. In total etch system, we over-etch dentin surface, and short duration of application in dentin adhesive may cause the failure of this infiltration to this area. So I apply acid etchant enamel first and short indenting to reduce the possibility of over-etching. And then rinse the acid etchant thoroughly and dry. But I highly recommend that do not over-dry on dentin surface. Over-dry of dentin surface can make the collapse of collagen fiber networks in etched dentin surface. If collagen fiber collapse, adhesive cannot penetrate to that area, so the bonding strength will not good. Apply adhesive after drying the dentin surface. Begin from the dentin to give a times of adhesive infiltration, not from the enamel area. During the apply of the adhesive, I strongly recommend not to use this kind of small dishes to put the adhesive in there. All the adhesives has a solvent. Solvent is very volatile. It can dry very fast. If you put the adhesive to the small dish, the solvent will dry, and it means that adhesive getting thickened, and it means that also loss of penetration ability to the collagen fiber network. So I put adhesive directly from bottle to micro brush and moved very fast to the cavity. After application of adhesive, the excess of adhesive should be removed. I use this kind of a blot out adhesive techniques. I use the same micro brush which I used during the application of an adhesive, and go to the cavity and blot the adhesive, go to the gauge to make a dry brush, and go back to the cavity, blot, and go to gauge, dry, and repeat this 3 or 4 times. By this procedure, we can remove the excess of adhesive, and also we can promote the adhesive infiltration by agitating rubber motion. After this application, it should be dried and then light cured. After application of adhesive, solvent should be removed because role of solvent is holding the many chemicals and penetrate to the collagen fiber network. After solvent penetration to the collagen fiber network, solvent doesn't have a role after application. And if the solvent is remained after application, it can make some reduction of bonding strength in the future. So the adhesive should be dried thoroughly after applications and then light cured. The next step is applying composite. My first step is applying floor composite to the deep area or here. Applying floor composite, can fill the deep and narrow area. And also, after applying floor composite, paste type composite can added with a comfortable. Floor composite is more flexible compared to the paste type composite, so it can observe the shrinkage stress during the polymerization also. The floor composite layer should have over 0.5 millimeter. It should be thin layer. And then I add a composite to fill the cavity, but you can see that I make a word in here that starts from the bottom of the cavity. As you know, composite has a matrix and a filler, and the polymerization happens in the matrix. In matrix, there are many monomers in there, and also there are initiators. When you apply light, the initiator will be activated, such as camphorquinone is activated, and it becomes as a free radicals. Free radical is not stable, so they move to monomer and also link to the monomer and activate also monomer to the free radicals. So activated monomer moves to other monomers and also activate also and moves to other monomers. This kind of reaction will be continued until make a polymer. We call this kind of a procedure as a chain reaction, making chain. During this process, the distance between molecule is decreased. So the decrease of a molecular distance makes some shrinkage of a composite. The result from shrinkage of composite, there is a micro leakage and poor adaptation and secondary carries, and also in post-operative hypersensitivity. Sometimes enamel micro crack or cause deflection when the bond strength is higher or stronger than the shrinkage stress. You can feel shrinkage of the composite very easy. Small amount of composite put on your fingertips and make a polymer rise. During polymerization, composite will hold your fingerprints and you can feel the displacement of the composite resin from your fingertips. Also, there is a concept of C factor, configuration factors. Contact surface or bonded surface hold the composite during the polymerization and makes the composite cannot move from the bonded surface. So stress will be generated in there. But unbonded on contact surface can move freely, so they don't have a stress or they release stress. So in this composite world, there are large area of a contact surface, bonded surface, but there is also more bigger area unbonded on contact surface in matrix side and inner side and occlusal side. So the stress will be less compared to the filling composites from the bottom of the cavity. After making wall, I added composite to the box area to fill the box, 2 or 3 layers. And then goes to the occlusal area to make a crucified contour. But in this in this step, I do not connect the buccal lingual or medial distal direction of the tooth. I made each cusp area do not connect at the same time medial distal or buccal lingual direction to reduce shrinkage stress during the polymerization. And then fill out the area and make a full contour and matrix is removed. During the composite fillings, we use instrument like this, scooping out the composite from the tip of the composite syringe, or cut the extruded composite from the tip. In these steps, sometimes composites stick to the instrument or make some small particles made, so the contour is not good. So I use this technique, make a small bore at the tip of the syringe and cut in here, so the contact surface to the instrument is very small and not stick to the instrument. And also during the fillings, we should not push the composite if it stick to the instrument, so we use tapping motions. Like tapping motions, it's more easier to make a contour. In the hands-on, after lunch, you will meet very specially designed, outstanding, special designed syringe, composite syringe. You may feel very great when you use this kind of composite syringe. After removal of matrix, we'll go to finish the contour of a composite resin. First step is using low-speed abrasive disc removal of the excess in the proximal area. This is after finishing the proximal area. You can see it very rounded, very smoothly connect with the two structures. And then adjust the occlusal margin and occlusal contour using a low-speed round burr, and also you can use a high-speed stone burr. After finishing the contour, we can go to the polish the surface. First, gloss polish with the low-speed silicone, such kind of the one gloss or pogo. In this step, we don't have to make a shiny, glossy surface, just to make a flat and even surface using this kind of silicone. After gloss polishing, we will go to the final polishing, make a shine surface using low-speed silicone brush in a low-speed handpiece and a very high speed in that bar. Then this is the final result of a posterior composite restoration. You can see the shiny gloss surface. Let's summarize about posterior composite restorations. For dentin, we should not over-etch the dentin surface and should give a long adhesive application time. And adhesive should be completely removed after applications. And also, we should think about the shrinkage stress instead of always thinking about the C factor during the filling the composite. And this is the last slide of the first session. So you can ask anything, everything for about composite restorations.